What has this unit really been about? What's the unit been about? Yeah, honestly, I'd say this unit more than anything is like computer science related. It's about programs. Taking multiple lines of code and either doing one then the other or trying to combine them into just one, more sophisticated line. What is the scratching sound going on? What is that? Okay. Understanding how things can be manipulated to produce different outcomes. Understand how you can manipulate things so you change like your inputs. Really just like programs, okay? And this lesson kind of ties along to that. We're going to talk about even and odd functions. Now, this is something that's actually new to you. You might think an even function is like, oh, well, that's like x squared. And you'd be correct, but it's more than just that. You might call an odd function as x cubed, and you'd be correct, but it's more than just that. Okay? Even and odd functions are useful because if you know half of the function, you know the entire function. So it's a way to be like, hey, I don't have to worry about the entire function. Again, trying to do like less is more sometimes is this unit. Being more sophisticated. If you know half, you know the other half. Okay. Why is x squared an even function? You might be like, oh, because the power is even. Like, yes, but the definition of an even function is the following. If you have a point, say 3, 9, an even function will be symmetrical about the y-axis, which means if you plug in -3, you get the same 9. If you plug in an opposite value, you get same as a positive value. Plug in 2, you get 4. Plug in -2, you get 4. Plug in a negative x, you get the same as what you plug in a positive x. That's what it means to be an even function. Even functions are symmetrical about the y-axis. You get the same y coordinates for opposite x coordinates. Okay? Same y for opposite x. You see x cubed and you're like, oh, that's an odd power, so it's an odd function. And like, yes, you're correct, but there's more to that. Odd functions are defined as you get opposite y for opposite x. You plug in 2 into the cube function, you get 8. You take the opposite x, you get the opposite y, -8. You can do it with any other point. Okay? You get opposite y for opposite x. Means that things are reflected both over the y-axis and the x-axis. Or we could say it's symmetrical about the origin. Visually, you can look at x squared and you see the symmetry. You have one point to the right, you'll have the exact same point to the left on the opposite side of things. If you look at x cubed, you have one point to the right, you'll have the opposite point to the left. That's what it means to be odd. Cool. You look at functions, and you'll be asked, hey, are they odd or even? You look at this function, and you're probably like, oh, it's just even, I'm going to move on. But I wouldn't do that. I'd be like, I think it's even, but I'm not sure. What are some ways to check? Well, you can use numbers. Plug in 2 really quickly. It's going to take us a while, so I'll do it with you. 2, 4, 8, 16, 32, 64. Minus 8 minus 8. So 64 minus 16 is 48. Cool. If it was even, when I plug in negative 2, I should get the same y value. Even functions, opposite x's, same y. Plug in negative 2, do you get the same result? 48. You do. Cool. Now, that is not sufficient. This is just 1 point. Okay? To ensure that it's even for all points, now this is where it's a little bit tricky. You should plug in or compose negative x into this function. This is what we did in the first lesson. We should understand, and we did it in this past lesson, how to plug in negative x into this function. We should use parentheses and substitute x with negative x. Now this is weird, but this can be simplified. I can always think of negative x as being negative 1 times x. I can always think of taking things to powers as the number to the power and x to the power. Well, if I take negative 1 times x to the 6, I get positive x to the 6. If I take negative 1 x squared, I'll get positive x squared times negative 2. I get the exact same thing when I plug in negative x as I do when I plug in positive x. That then confirms that it's even. What? A minus what and minus x? Oh, nothing. It's just like this I got the same y value for. That makes me think that it's even. And then I checked for all x's by plugging in negative x. Okay. So Schreier. Schreier's got a good question. Like, why did I plug in minus x? Pay attention. All I did was one example. We could have gotten lucky. By plugging 2 and negative 2, we might have just happened to have gotten lucky and there's 1 point where the y value is the same. We're not 1,000% sure that it's going to be the same for all points. Like what? If it was 3 and negative 3, I'd have to check that. I'd have to check it for decimals. This is checking for all opposite x's compared to the original x's. So this is just kind of like a test point. And then this is like ensuring that it's true for all x's. And that's why I say it's even. Okay? Now, you think, oh, square must be even. Well, first thing I would do is use a couple x values and check. And right off the bat, if you don't get opposites or the same y value, you know it's not even and it's not odd. So, I don't know, let's take 2 points, 2 and negative 2. Go ahead and plug in 2, plug in negative 2. What do you get? You get the same y for opposite x's. If you get the same y for opposite x's, it's probably even. Do it. Oh, so it's even. I see x 2x minus 4 squared. It must be even. Oh, so it must be odd. Woods has got this. This is a piece of cake. Everybody, Jacob Woods is going to teach the rest of the lesson. Jacob Woods says, oh, it's outside the parentheses. It must be odd. All right, Jacob Woods wins hundreds on all of our tests. Oh, we said even. Okay, so we're even. All right, we're back to even. That's what I got, Linder. So I check with points, Jacob Woods, because I'm paying attention, and I get 0, and I get 64. Do you get the same y's for opposite x's? No. Do you get opposite y's for opposite x's? No. We know for a fact that this is not even, and it's not odd. Fang, what's your question? Can you just what? Sure, but guess what? This probably took less time. Well, now the question becomes, it's like, all right, so Woods, having a square doesn't mean you're even. It all depends on the situation. We'll look at when things are definitely even. Let's look at the next example. Here, we got x cubed plus 4x. I see odd powers. I think it's odd, but I don't know for certain, Woods. I will always check is the key to this lesson, okay? Don't just assume, because you're probably going to be wrong. I'm going to start by plugging in -2 and 2. See what the y values are. Okay, I got -8 minus 8, which is -16. I got +8 plus 8, +16. Opposite x's, opposite y's. Okay, I'm feeling pretty good about odd. I'm like closer to putting an exclamation point and circling it. But we got to double check for all opposite x's where we get the opposite of positive x's. I plug in -x cubed. I add 4 times -x. Think of the negatives as being -1s. -1 cubed is -1. X cubed is x cubed. This stays as -x cubed. 4 times -x is -4x. I can see that for opposite x's, my y's are opposite. We are 1000% odd. Okay? That's an odd function. Once you know it's an odd function, you know if you know one half of things, you know the other half of things. This helps us simplify things. Like less code required. If you know the right half of your graph, you know the left half of your graph because it's just opposite x's and opposite y's. Okay, cool. We look at the next example and we see a 5th power. We see a +1. Oh, no big deal. Those are both odd numbers. So we're probably going to just write down odd, and we're probably going to just move on because we're not paying attention, but I'm not sure. So go ahead and check. I apologize for my voice. But I am getting over something fierce.
I didn't understand. I thought this is even. It's not even.
It's not even. You thought it was. It's not. The definition of even is opposite x's, same y's.
Oh.
So just because you have an even power does not necessarily mean you have an even function. It is a neither. You think it's odd. You see an x to the 5th. Shh. You think it's odd, but all it takes is one counterexample to show that it's not. -2 to the 5th is -32 plus 1 is -31. 2 to the 5th is 32. 32 plus 1 is 33. This is not odd. I would always start with points, team. And words of wisdom. Shh. Stay away from 1 and -1. 1 and -1 sometimes can deceive you. Okay? Stick to like 2 or greater than 2. just one set of points that are not what you're looking for, boom, it's neither. It can't be an even function. You don't get the same y's. It's not an odd function. You don't get opposite y's. All right. So then you're like, okay, it seems like we have all even powers means even. All odd powers, but without an extra number, odd. We see this function, it's got an even power and an odd power. You're probably thinking it's a neither, but check. Figure it out yourself. Figure it out yourself. Use some numbers. And again, this knowledge helps simplify things. You know half of your function, you know the other half of your function. So what is it, Thomas?
Which one?
This one that we're working on.
It's odd. Even.
I just heard odd, I heard even.
I got odd.
We got odd, we got odd. What do you got? You got odd. We got even. What'd you get? Odd? Even? Neither?
It's even.
It's even?
No, sorry, it's odd. It's odd. It is odd.
What'd you get, Schreier?
Wow.
What'd you get, Carter? Now, team, just using 1 point and its opposite does not guarantee you are correct for all of them. 2/5, -2/5. Opposite x's, opposite y's. Yo, it looks like it's odd. But I got to double check for all opposite x's. When I plug in -x and square it, it's +x squared. When I plug in -x for x, it's -x. This is the exact same as the opposite of f of x. This confirms -x's, -y's, opposite of y's. It's definitely odd. What about this guy? What, you're on fire. You're like 4 from 4. Let's go 5 from 5. F of x equals x e to the -x. Is it odd, even, or neither? You've gotten a lot wrong.
I'm actually 1, 2. I'm 4 for 5. You got both neither wrong. I got that right.
Thomas is going to get this one for us. Thomas, x e to the -x. Odd, even, or neither? Neither is correct. All it takes is one counterexample to know that it's a neither. They look opposite of each other, but you guys know better than that. This is 2 over e squared. This is -2 times e squared. These are not the same. They are not opposites. This is a neither. It's a great example because it looks like they are, but they're not. Symmetry. Now, really quickly, let's start with, I want you guys to tell me if it stays even or switches to a neither. If I add, Woods, you're killing me. If I add x to x squared, do you think it's going to stay even or switch to a neither? Tell your neighbors. If I add x, here's x squared, I'm going to add x. What do you think? If you have even and odd powers, you lose the symmetry about the y-axis. We want 1, 2. I should have -1, -2. I don't. X squared plus x is a neither. What if I switch it to x to the 4th? Do you think It'll be even or it'll be different. Good. If we switch this to x to the fourth, even. What about my coefficients? What if I make this a 3x squared? I'm going to put an odd coefficient in front of things. Will that change things? Go. You sit over here. You're sitting back there. Wood, sit over here by yourself on that side. Yes, you are the closest person to that side, so I'm moving you. I'm about to then move you or move you so that you could stop talking while I'm trying to teach. Look over there. That's your board. All yours. If I put a 3 in front of x squared, that's an odd coefficient. Is that going to change the symmetry, or are we still going to be even? You're correct. We're still even. What if I put a 3 in front of this? Still even. What if it's a negative? Whatever. What if it's a negative? Still even. What if I add 2 to this function? What happens, Linda, if you add a number to a function, f of x plus 2? It goes up 2. If you take that graph and go up 2, is the symmetry lost? No. If you add 2, even functions stay even. So, team, down at the bottom of the next page, what if you subtract? It would be the same. What guarantees f is an even function? P and Q must be even. A and B could be anything. And you could take your function and vertically translate it, and it's still even. You will still get the same y's for opposite x's. Because when you vertically translate, you're just going to add 2 or add whatever to all the y's. Change this to odd. Let's go back to x cubed, our original odd function. If I add x squared, do you think it's going to be odd? It looks like it, but it's not. You have to see opposite y's and opposite x's. You see the point 1, 2. You would need to have the point 1, negative 1, negative 2. You don't. So even though you think, oh, it kind of still looks like x cubed, this is a neither. What if I change x squared to x? Good. This has that reflective symmetry, reflecting x's and y's that's symmetrical about the origin. If I add a number, tell your neighbors, if you shift things up, if you shift things up,
Why would it be an idol?
you tell me. If you shift things up, would it still be odd? This is a beautiful odd function right here. This is perfect. Here, we have the point negative 1.342, 2.898. Here's the opposite x and y. If you shift things up, will we still have opposite x's and y's? Tell your neighbors. If you shift this point up and this point up, are you still going to have opposite x's and y's? No, definitely not. Look, now we have, sorry for the voice, 3.898 as the y. This is not 3.898. This is negative 1.898. So we're allowed to shift even functions up. We are not allowed to shift odd. So if you're an odd function, P and Q must be odd, and this is polynomials. It's not just in general functions. These are polynomial functions. P and Q must be odd. A and B could be anything. No, we'll talk about polynomials as always having positive degrees. But no. Things change once you go to rational world. Cool? Now, what you're going to see on your homework is like, hey, we got this function. This is even. Is P plus Q times A plus B even? Yes, no, or I don't know. Tell your neighbors. What you're going to have to investigate is relationships between even and odd numbers. An even plus an even. What does an even plus an even have to be? Even. Write that down. What does an odd plus an odd have to be? 3 plus 1. 4. Even. What's an even plus an odd? Good. What is A plus B? Well, A could be anything, B could be anything. So this could be even, this could be odd. I'm not sure. But what's P plus Q if this is an even function? If it's an even plus an even, this has to be even. Okay, cool. Now the question is this times this have to be even? Well, what is an even times an odd? What's 4 times 3? What's 4 times 1? What's 6 times 3? Even. What's odd times an odd? What's even times even? If you have an even times an even, you get an even. You got an even times an odd, you have an even. A plus B times P plus Q has to be even. Cool? You'll see some questions like that. You'll have to understand what your values could be. But, go to the last page really quickly. If you have an even function that has a max at -4, what's happening at 4? No, if it's an even function and there's a max at -4, since things must be symmetrical, we have to have a max at -4. If you have a max at -4 and it's an odd function, what do you have to say at 4? It's a min because of the different symmetry. Keep that in mind. My voice is gone. I'm glad I recorded that. It's going to sound great on YouTube. It's going to be great.